Okay, for this lesson, we are going to go back and also list all the isotopes and any points of discontinuity that we did from the previous lesson, along with now we're going to also add in the part where you are to make the picture as well. So first, let's start with our old stuff. I would remind you that you want to GCF or factor the top and the bottom. On problem number 1, can't do anything with x minus 2, so I'm going to leave that alone. On the bottom, x squared minus 4, that can be factored. Hopefully you're thinking difference of squares. So x minus 2, x plus 2. And then we always look to see if something cancels out. I say, oh, look, x plus 2's cancel out. And remember, if everything cancels out, you're left with a 1 on top. And then on the bottom, we have x plus 2. So my VA, you look at the bottom, switch the sign. So x equals negative 2. For HA versus SA, go back and look at the original problem. And the top exponent is smaller than the bottom one. So if it's bottom heavy, it has an HA. And we said it was always y equals 0. And then remember, if there's an HA, there's no SA. Now we will have a POD because something canceled out. So for POD, we look at what canceled out, which was x minus 2. If I solve that, I get x to equal positive 2. Then plug 2 into what you have left. So that would be 1 over 2 plus 2, which would be 1 over 1/4. All right, now let's go ahead and put some of this onto the graph. The VA is going to be a vertical dashed line going through negative 2 on the x-axis. Then you want to plot your horizontal, which would be a horizontal line at 0, which would be ended up being right on top of the x-axis here. Then if you have a POD, we want you to plot that. And remember, when you plot that, you're going to plot that as an open circle because it doesn't count. So 2 and then up a fourth, you're just going to kind of guess the best of your ability. And there's my open circle. Now, to help you get the rest, you should have a graphing calculator that you'll be using. Or if you're not using a graphing calculator, you should be plugging it into Desmos. So now I'm going to switch over to mine. So remember, go to the y equals key up at the top. And then I want you to type the top in parentheses. So on the top, we had x minus 2. So x minus 2. Make sure that's in parentheses, divided by, type the bottom into parentheses. And hopefully you're noticing that I'm typing in the original problem, not the simplified. Just because I want to show you a few things that you can only see if you type in the original that you can't see on the simplified version. So just remember, top in parentheses, bottom in parentheses. Okay, so now I'm going to hit graph so that I can see my picture. And you're going to notice rationals are going to be some kind of curves. Okay, so I have two curve shapes. Now, to help me with these, I'm going to go ahead and go to the t-table. So second graph. And I'm going to get a t-table. Now, here's some things that you can notice on your t-table. If we go back to the original, we said our vertical asymptote was x equals negative 2. And right here at negative 2, does everybody see it says error? Okay, so that's telling you that's where the vertical asymptote is. So if you said the vertical asymptote was negative 5 and the calculator doesn't say error there, then either you made a mistake calculating or typing it in. The other thing I wanted to point out is our POD we said the x value of our POD was positive 2. And if you look at your t-table at positive 2, it also says error. Now, it won't give you the y value because it says that point doesn't really exist on your picture. And then the next thing I always get is, oh, well, Ms. Meyer, I'm looking at the picture, but I don't see that. I don't see a POD. I don't see a gap. Well, you would have to zoom in tremendously into this portion right here and able to see it. And we're not going to do that, but just trust me, it is there. So now when I'm back at my t-table, what I would do is your vertical asymptote, I would try to pick like 3 points above it that are nice and easy to plot. So I'm going to go -7 and -0.2. So -7 and -0.2. Then I'm going to go -4 is 0.5. So -4 is 0.5. And -3 was -1. And then an error, so I'll put one line there. So now I'm going to go plot these. So I'm going to go to -7, and then I'm going to go down to about 0.2, my best guess. Boom. -4. So here's -4. I'm going to go down a half, best guess. And then -3, -1. And then remember your picture that was on your calculator. It's going to follow this asymptote right here. It's going to start to curve, and then it's going to follow this asymptote on the way out. Now you're just going to do the same thing from the other side. Okay, so the other section. So now I'm going to do -1, 1. So -1, 1. 0 was 0.5. And then let's see if we can find anything else that might be better. Probably 3 is maybe 0.2. That might be the best one. Or you can do 8, which is 0.1. I guess we'll do 8, which is 0.1. Okay, so now I'm going to plot those on this side. So -1, 1. 0.5, and 8 is 0.1. So remember, it's going to follow this asymptote, hit these curves. Okay, there's my open circle for POD, and then it's going to come off that and follow it out. Now, when you looked at this problem, hopefully you were okay with the VA, the HA, the POD, putting the dashed lines in on your picture, plotting the POD if you have to, and then going to the calculator, getting some points off the t-table to draw in each curve. And then you're finished. Okay, let's try the next one together. Oh, the top does not factor. This is not factorable. Okay, so this problem does not simplify. And if it does not simplify, that means there is no POD because nothing cancels out. So if I start with VA, I just look at the bottom. So I'm going to do x equals +1. Now, if I compare my exponents for the either HA or SA, the top is 2, the bottom is 1. This one is top heavy. And if it's top heavy, then it has a slant. So no HA, but yes to SA. Okay, so I'm going to make my little corner box, put your VA answer, which was 1. List your coefficients from the top, which is -2, +2, -1. Drop, multiply, add, multiply, add. But we don't care about the remainder. So then we have our mx plus b. So you got y equals negative 2x plus 0, or if you don't want to write the plus 0, that's fine. Okay, so VA, go to positive 1 and put a dashed line. Now the slant, okay, this one you're going to graph old school, y equals mx plus b. B is 0, so you're going to start in the middle. Your slope is negative 2 over 1, so you're going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Then you can do your slope backwards. Up 2, left 1, up 2, whoops, that's not up 2. Up 2, left 1, up 2, left 1, up 2, left 1. So then you're going to have your asymptote here, which I think I got one off right there. Here we go. That looks much better. Okay, so now we're going to go to our graphing calculators. Okay, so I'm going to go back to the y equals key. I'm going to clear out what's there. And then remember, you have to put the top in parentheses. So negative 2x squared plus 2x minus 1 divided by, please remember to put the bottom in parentheses as well, which is x minus 1. Okay, if you want to see a picture, you can hit graph. Okay, and then you can kind of notice right here, this is where they're following the slant. And then this one right here is where they would be following the vertical. Okay, so to help me out, let's go to our t-table. We said the vertical was at 1, so it does say error next to 1, so yay. So what I would do is I would just pick some numbers to the left of the error and then to the right. So I'm going to go negative 3 is 6.25. Oh, positive 62125, sorry. And then I'm going to do negative 1 is 2.5. And 0 is 1. So now if I go to plot these, I'm going to go to negative 3 up to 6.25, which is pretty close to my line there. And then negative 1 is 2.5, which is pretty close to my line right there. And 0, whoops, hold on. I'm plotting these on the wrong part. Excuse me, sorry. Let me get them in correctly. They should be on the inside of the line. So 6.25. So on the inside here, yes, please, please. Sorry. 2.25. Here we go. On the inside. There we go. That makes much better sense. Okay, so now it's going to come in and follow this one, and then curve and follow this one. Okay, and then we'll do the same thing for the one down below. So I would pick 2 is negative 5. 3 is 6.5. And 4 is negative 8.3, which would be a little bit off my graph here. So 2 is negative 5. 3 is negative 6.5. And 4 is... So it's going to follow this asymptote curve and follow this one. Done. Yay. Okay, so I want you to go ahead and try the third one by yourself. see how far you get before you have to look at it. I will just tell you that this one will have 2 VAs, which means instead of your graph only having 2 parts like the first 2, since there's going to be 2 vertical ones, it'll now be split into 6 sections, so you should have 3 parts of a graph. But anyway, before you even get to that, just go and do your regular stuff. So if you're at the part where you're looking at the graph, hopefully you notice here when I draw in my isotopes, there is 1, 2, 3, 4, 5, 6 parts. So if there's 6 parts, you must have a graph in half of those. So you'll notice here we have 3 portions. Okay, so you need to find about 3 points or as many points as you can. Sometimes it might be only 1 or 2 depending on the picture, but for each part. So, whoops. So verify my VAs, boom, boom. Okay, so then hopefully everybody's got the first part. There's my middle part. And then here is my last part. And we are finished.